Hangout is live.
Let me make sure I look good. Okay.
I got a guy. He can line you up.
Huh?
I got a guy. He can line you up.
Okay. I don't know that term. Line you up.
Give you a good haircut.
Oh, okay. I cut my own because it's cheap. How much does he charge?
$20.
$20.
Whoa.
Man, that was the machine that I bought.
Yeah, me too.
But okay, let's keep working on this.
Hey, Gabriel, I'll cut your hair for $2. I'm just kidding.
Okay. List the transformation made to the cosine function and write an equation of the form. Yeah, I want to write this time, so I always do that.
Are you doing the hangout, or you just started on the quiz?
In the quiz, right? Are we gonna do the hangout too?
I just do the quiz and just call it good.
Yeah, let's do that.
Yeah.
Yo, having a textbook helps so much.
Bro, I'm excited to get that from you.
Yeah, me too.
Yeah, I'm gonna go to Idaho Falls tomorrow anyways, so I could drop it off.
Really, I'm gonna be at. I come to campus Monday, Wednesday, Friday.
I'm going to like Social Security office. So,
Oh, are you?
yeah,
Why?
but I don't know what time yet. It's like I
Get it-
want to donate plasma, so
Oh,
I might have to take you up on the Vivint thing on Saturdays to work
yeah, dude, for sure. Let's do it.
because I need to like refinance my car, and they're like, you have to have a job. So like, okay,
Where are
So,
you refining it?
huh?
In a credit union?
Freshman man.
Huh?
What?
Where are you doing that for your car?
Oh, because I got a car, and speaking of math, I got a really high interest rate, like 24%. So,
Whoa.
yeah,
You should go to Mountain America,
Mount
the
America.
credit union.
Yeah,
Yeah. My friend went, and they have a really low rate.
That's
It's
good.
really
Because I'm not like worried about credit anymore because I have like 700 right now. But
cool.
yeah, I just want to.
So you wanna pay less money.
Yeah, I'm getting wrecked right now by that interest.
How much do you pay?
I pay like 280 every month, but it's like basically just going in the trash with that interest rate.
For sure.
And insurance and everything extra.
Yeah, for someone that's under 24 years old, 25. So.
Man,
What do
I
you
don't
drive?
get a because I don't want to spend that
Corolla
money.
in 2011.
That's not bad.
Yeah, it drove me across the nation, so it's good. I think. Nice cheap car.
Oh, here we go. Okay, so we have here pi over 2. It is 2. What does that mean?
So the first coordinate's pi over 2, comma 2.
Mm-hmm.
The second one. Five.
It's pi, comma pi 4, right? And then 3 pi over 2 is 5, right?
Yeah, 3 pi over 2 is.
Okay.
It doesn't look like it evens out very well. the third coordinate looks like it's like halfway between 2 and 3. I don't know if it's because they made the graph like that or something.
Yeah, I bet that it's just because they use a computer.
It's closer to 2.
Yeah. But how will we know what exactly is? But I would say that it would be 3.
Okay.
Just because the other one, there we have
Yeah, that's true.
3 pi comma 0, and then 7 pi over 2 comma minus 1. Okay. List the transformation made to the cosine function. Oh, the first one, is it -1? Never mind. Okay. So we have all those transformations, do we? Like pi over 2, pi, 3 pi over 2, 2 pi, and all that stuff. 5 pi over 2.
Hold on. Did you guys say the second point was 3?
No, 4.
Huh? Oh, the fourth point, excuse me.
The 4.
Yeah.
What do you mean, the 2 pi?
5 pi over 2. Are you guys on the quiz? You guys are on
Yeah.
quiz, right?
5 pi over 2 is 3. Even though it's a little bit off.
No, it's not. It's 2.
It is?
Yeah. It's, guys, the cosine curve is going to follow the same thing. So the pi, 2 pi, pi over 2, 5 pi over 2, 3 pi over 2 are going to follow the exact same spots. So like pi over 2 and 5 pi over 2 are both going to be at 2. They're not. It's not going to be 1 at 3 and 1 at 2.
Okay. Gotcha. So they should be the same.
Yeah.
So
Time for the return of the whiteboard. All right, I'm going to draw this. What a horrible drawing. Gosh, it's a horrible graph. Okay. So, okay, where are you guys at on it? Hello?
Hey,
What are you guys doing?
I'm just looking at the parent of cause.
Okay.
okay. Yeah, I'm just trying to find examples in the book. And as always, it is in the material of the next week.
Huh. I think it was in the material for this week.
The 5.2.
Yeah.
But the graph of the sine and cosine functions is in the 5.3.
There was a section in the homework. I think it was in the week or the lesson 3 resources. Lesson 3 or lesson 4 resources is like graphing the period or something like that.
I have done all that, but I don't remember.
That's technically our textbook, right? Part of our textbook? Or is that the internet? Can we use it or can we not?
What, the book? Yes, the textbook. What can we use?
No, the resources that they gave us to do the homework.
Wait, you said that it is in where?
The
Which?
lesson 3 resources.
Oh, graphing, yeah. Graphing with a period change, done?
Yep. Mm-hmm.
Gotcha, here it is. I'll be back, I need my charger. And laptop. No. What are you in? Okay, so
this is a cosine. So if this is a graph of cosine,
right, that looks pretty.
it's not.
Take it as a compliment. That's it. Don't worry.
Oh, thanks. I appreciate it.
Okay, so we have that, and we need to identify the transformations that.
Okay, so
There are a lot of transformation firms, or at least 4 that I see.
they're the same. They're the same thing.
Okay, so first let's find the curve. It has a period of 1, right?
So
Because it goes up 1 and then it goes back.
right. So the
first transformation, it would be,
this is one whole transformation
yes,
because this is the halfway point.
right, and that is 3, no, 2, I can see. Yeah, 2. That's the no.
Yeah, it's 2.
It's 2. Okay.
But remember that a normal cosine, so like a normal cosine graph should look like if this is 1, it should look like this.
Let me listen to this.
And let's say this is x and y. The curve, so this curve should be right here. If it were cosine, like cosine of x.
Okay. That's, yeah, you're right.
So for one whole period, so here let's start with something easy. What's the range?
Infinities.
So the range is -1, 5.
Negative.
Like we know that for sure.
Good. -1. Okay.
-1 is the bottom, 5 is the top. That's the most it'll ever be.
Okay. Good. Do you want? Okay.
Right?
Hey, there is a video here in Khan Academy that they had in their source, and they are graphing the cosine and everything.
But we're not allowed to use the internet.
But it's part of the homework.
Gosh, we're getting into some gray areas. What? I don't care.
Okay, let's use the calculator and graph it. I'm gonna graph the cosine. And get some value of the. moment. I don't know.
Okay.
Do you guys have any idea?
Yeah, I'm figuring it out right now.
What happened to you? I can't see you.
Huh? You can't see me?
Uh-huh.
Can you see me now?
No?
Really?
I see you standing. I thought you were like standing there looking at the whiteboard like for half an hour. That's what is stuck.
Just in thought, in serious stupor, huh?
Uh-huh.
Nope. Okay. Oh.
What happened?
Okay, so normal cosine x, right? So this one, cosine x has a period of 2 pi, right? Okay. Our period on here is 4 pi. So that just means that this number, b, is 2.
Okay. Oh, okay. Hey, why I can't see you?
Can you not see me again?
No, I'm not able to. Vladdy, can you see him?
Yeah.
Yeah?
Shake
It's
my
you.
head.
It's not me. It's you. All I see is a picture of your. Is it you?
2 little boys holding hands.
Oh, now I can, okay. I just kind of close the elbow again. You are still standing the same as like 30 minutes before. Okay, so you're right. It is 4 pi, that's what you said? And 2 pi is the standard number for the cosine of that?
Yeah, so cosine x has a period of 2 pi.
Period.
Our period is 4 pi. So theoretically, you're just multiplying the period by 2, right?
Yeah. Exactly. Yeah, if we just need to double the.
And then if this is the center point, which means that it's moved up 2, okay, that means that this is 2, right?
Yes.
And then normally your y-intercept would be here on the graph. So this one has moved over 3 pi over 2. Now what I can't figure out is whether we need to factor out 2 from this, or if it's already included. So the possibles are, like, to me, this equation is 3 cosine, y equals 3 cosine 2, it's either 2x minus 3 pi over 2 plus 2, or it's y equals 3 cosine 2x, oh, not this, hold on, 2x minus 3 pi over 2, but you need to factor out the 2 plus 2. Does that make any sense to you guys?
Kind of, yeah. I don't get this yet. Okay, Bloody, so for Zach, I would do what you just did.
What?
Let's put what you have, Zach, and what else? What was your question? You said that you weren't sure. Hmm? Zach, we can't hear you. You
I'm
disappeared.
muted.
Huh?
Can you hear me now?
Yeah, you were muted.
I don't know how I got muted.
Yeah, me neither. Maybe if you were talking, we didn't hear anything.
Great. I wasn't talking though.
Bloody, if you're talking, you are muted too, Bloody.
No, I'm just kidding. I was just like,
I know. Okay, so do you have you have the formula right there below, right? You have the transformation y equal in the form beta.
Hmm?
Okay, what else do you need for us to be done with that? What is it that we need to work on?
Hold on. Yes, I'm sure. What do I need to be done? I don't know. I don't know the answer to that, guys.
Me neither. I have tried to look the examples. And the question lists the transformation made to the cosine function and write an equation of the form whose graph is the given cosine function. In the textbook, there are some examples.
What does it say?
But I don't know if it is like too simple because they use just the function with the graph. Like, for example, wait, changing the period, no, it's not that one. Sine and cosine. No, different. The graph of y equal cosine of x. That's our one, right? Then No, there are 5 key points on the graph. I want to find it. No, it's completely different.
Is this in the next week?
Yeah. And then they have the general sine wave, and that is the cosine function that they're asking us. And then the procedure for graphing it. To graph y equal a cosine, sketch one circle of y equals sine bx, or y equal cosine of bx on 0, 2 pi over b. Change the amplitude of the circle according to the value of a. So I think that the instructions here are to graph it, but we have the graphs and we have to come up with the equation. If a is less than 0, apply the curve in the x. Okay, wait. Okay, so we have our d, it will equal 2, right?
Huh?
Our d is 2.
Yeah.
And then we need c. Or c is pi over 2, but you modify the pi over 2.
You think it's pi over 2?
Yes, because that is the coordinate that it is in, like, or the average. It's like pi over 2 and 5 pi over 2. Look at, if you go to the page in the, can you access to the book?
Mm-hmm.
The page 369.
Oh, no, I don't have access to the book.
Okay, there is an example there of the, well, is the sine of this or the cosine, but it is in the same form. And comparing the function with the graph, how they get it to graph it, and comparing it to the graph that we have, I will say that our c, because it's negative, and in our that is positive. Yeah, I would say that is pi, or c is will be pi over 2. We can try to do it, and we can, maybe we can put the function in the calculator and see what we get. And then our x, well, our x is x, and then our b, oh, our b is 2. Is the denominator of the equations. And most, yeah, our b is 2.
So your B is 2? Why is it 2?
Wait. Because it's y equal cosine of 2x, right? Or what do you?
So this is the only part that I'm having a problem with, because I know that the graph is moved over 3 pi over 2. So I think C is 3 pi over 2. The problem is the graph stretched or is it compressed? And what does that mean?
Oh, and that is our B. What is it stretching it or shrinking it, right?
Yep.
That's your.
So it's either 2 or half.
Let me see if this function.
It's either 2 or a half. That's the answer.
Okay. Let me see if it is because it's 3. And 2. Okay, let me see if I can graph this. And that way we can.
I think it's a half. Because I think if you do 2, then it puts more sine waves or cosine waves in the area. Does that make sense? So like it doubles the amount of waves that are in the area.
Yeah, that makes sense.
So because the normal period is 2 pi, meaning that in 2 pi you'll have 1 sine wave. If you were to do 2, that would mean that in 2 pi you have 2 sine waves in 2 pi. Whereas because our period is 4, we have half as many sine waves in the period.
Right.
So I think personally that the equation is this. It's y equals 3 cosine 1/2 x minus 3 pi over 2 plus 2.
Okay, plus 2. Let's graph that one and the other one.
Okay. Did you graph it?
I'm still learning to use that calculator.
Okay, let me do it.
It's really challenging. Yeah, sorry.
What are you doing, Vladi?
The project.
You're what?
Nothing.
What did you say?
You can scroll in the YouTube video 42 minutes in.
Oh, yeah?
No, I just quit on it because I was like, I need to study this more. I don't want to like come up with the wrong answer with you for you guys.
Yep, that's the one. So it's half. Yeah, that's right.
Yeah,
Huh?
let's put that one. I don't.
That's right. I just graphed it. That's right.
Okay, great. let's move on to the.
Number 2. We thought this one was going to be so fast.
What made you believe that it will be like so fast and now we're already in one question?
I don't know. I was
Okay.
mistaken.
Find sine of alpha, given that cosine of alpha is 2/5 and sine of alpha is less than 0. Okay, let's see if we find an example.
I'll be right back. I have to go to the bathroom.
Go for it. Man, I'm done. Bloody, I'm done.
You got the answer?
Huh?
You got the answer?
No, I'm done with the quiz. Quiz. Do you know any? Yeah, I don't know. Freaking thing.
When you think you know something and then you're like, don't know anything once it comes to it.
Graphing that thing. I'm trying to find examples at least or something, but I can't. I haven't find anything. Hmm.
Okay. What did you guys figure out?
We're done.
I love how you said we're done. Vladi goes like this.
We're done with the quiz.
Oh, you give up on the quiz. That's what I heard.
No, but we can do it. I will
You-
find an example for this one.
You can do it.
Even though I think that it's not that hard. I mean, we just need a triangle and we have the cosine. Sin of alpha given that, okay, this is our alpha. That the cosine is 2/5. And if we use Pythagorean, it will say that that's the square plus 2/5 to the square plus x to the square equal.
So that means that, so if you use the Pythagorean theorem, cosine is equal to the adjacent over the hypotenuse, right?
Right.
Which means that this is 2/5. So is it a squared plus b squared equals c squared?
Wait, what did you say? A. Yeah, a squared plus b squared equals c squared. Yes.
Okay. So that means that the adjacent is either a squared or b squared, and the hypotenuse is, so this is 5. One of these is 2. So you have 5 squared, or 5 squared minus 2 squared is equal to b squared, which is the opposite.
Yeah.
And so if we know that, then we can write sine of it.
That's what I'm trying to. Okay.
But I don't get the whole sine of a is less than 0.
We need to make sure that it is. It's because, well, it has to be less than 0. Because our cosine is 2/5, and that is like 0 point something. But just a second.
Because the
No, man. We do need the hypotenuse to get that. Okay.
We already have the hypotenuse.
What do you mean? What value did you give it to it?
5.
Oh, because it's 2/5.
Mm-hmm.
Okay.
Given that cosine of A is equal to 2/5, and sine of A is less than 0.
So is the square root of 21?
Yeah, that's the square root of 21 over 5.
There we go. So that is the answer, isn't it? And if we said that, yeah, it is less than 0 because the square root of 21 is like 14 something.
It's 4 or something.
Yeah, so that will give us a value less
It's
than
not.
0
How is that less than 0?
because it is over 5.
That's not less than 0, though. That's still over 0.
If we have like square root of 21, that it is 4.5, divided by 5 is 0.9.
That's still more than 0, though, isn't it?
Huh?
Isn't that still more than 0?
No. No. Oh.
Yeah.
Yeah, you're right. 0.9. But
So,
it will have to be negative then?
Lonnie, what are you doing? What? You're cleaning your room.
No.
Okay, so we need to find a negative value for that thing. But that doesn't make any sense. And sine of less than.
I mean the parallelogram theorem, the fundamental idea.
I got my grade on my written portion of my exam.
What you get?
76%.
Woohoo!
Noise.
I've never been happier to get a C.
Was terrible.
I want to stick like a fork in my face or
Man,
something like that.
in the multiple
Okay.
choice quiz, how have you done, guys, in that?
Good. I got 100% on the last one.
I always get one wrong, and it's like, whoa, it sucks. I was like, thinking like, what's wrong with this? Okay, so what are we gonna do then? Or answer doesn't.
So,
It has to be negative, and
well, and that's fine because it's squared to find the answer. So, it's okay that that's the case.
exactly. There you go.
It doesn't really matter. It's just the negative. It's the negative of it.
Exactly. There you go. You have the answer right there. It has to be negative, and it doesn't matter because it's a square. It's gonna be positive. You're awesome.
25.
Okay, let's move on to number 3.
21 plus or minus 21. So then it's just going to be, so then, hold on. I just want to make sure I have this down. So sine.
Cosine of 2 over 5
Sine
equals sine of
negative the square root of 21 over 5.
right.
Okay. All right. Yep. That's good. I think that's right. I could be 100% wrong, but I think that's right.
Yeah, yeah. Let's just do that. Yeah, that looks good. Use the fundamental identity to write two functions for cosine A in terms of sin A. Indicate which formula to use for a given value of A. Okay. So we need to use the two
identity.
functions for cosine of A. So the cosine of A cosine of this it will, do we have to use like for example A over C, something like that, or B over C? Fundamental identity, I don't remember that.
So that's like sine is equal to 1 over cosecant. Cosecant is equal to 1 over sine. Cosine is 1 over secant. Secant is 1 over cosine. Tangent is 1 over cotangent. Cotangent is 1 over tangent. Tangent is equal to sine over cosine. Cotangent is equal to cosine over sine. So one of them is sine is equal, it's in terms of sine, right? So we have to, in function for cosine A in items of sine. So cosine is equal to sine of A times tangent of A is one of those. Right. Oh boy, I feel a bad grade on this quiz coming on.
Man, in this one? No, we have the answers. And I feel really good about the first one that you were doing it because I compared it to the example and then you graph it. And then this one, and now the third question. I know what you're saying is true. Okay, so you said
I don't get what it means when it says indicate which formula to use for a given value of A.
It's because there are two, as you say, there are two ways. We can use the tan sine of A times tan of A. That is one. And what about the question that I asked you before, the, like for example, the cosine of A equal to the whatever word you said that is the opposite of sine.
Reciprocal.
Reciprocal of sine of A. Yeah, but there is a word for that.
Inverse.
Oh, huh? The cosecant.
Cosecant of cosine or sincant or cansine. Yeah, I don't remember that.
Sine's reciprocal is cosecant. Cosecant or cosine's reciprocal is secant.
Exactly. So the cosine of A is the reciprocal of sine. And sine, you call it cosine something. Yeah.
Find it.
Further.
Find it.
Huh?
Find it.
Okay, I don't remember that then. When am I gonna find that?
I don't know. Find it. Goodness sakes.
What is the name?
Cosecant and secant.
How do you spell it? C-O-S-I?
SECANT.
S-E?
CANT.
D?
T as in Tom.
C-A-N. T-A-N? Cosicanta? No, cosicant.
Hold on. I'm gonna write it for you.
There are no records in the book.
It smells like it's burning in my house. Did you find it?
No, there is nothing of that in the book. Okay, so what about, okay, we have this is hey, we can use Pythagorean theorem too, do we? Can we?
We could.
We can say that or cosine of A equal equal to the sine to the square. Yeah, cosine A squared equal tan squared minus tan of A squared.
I guess I just don't understand what they're asking for.
Yeah, it's too general. Use the fundamental identity. Okay, let me see if I can find that in the book. Okay, the fundamental identity. An identity is an equation that is satisfied for all values of the variable for which both sides are defined. The most fundamental identity in trigonometry involves the square of the sine and cosine functions. You see, is sine square of sine A squared plus cosine of A squared equal 1. What is the fundamental identity of trigonometry?
Oh, yeah. So sine A equals cosine, or it's sine A squared is equal to cosine A squared minus 1? Or 1 minus cosine A squared?
1 minus sine A squared.
Are we doing this in terms of cosine or sine?
The cosine A squared.
For cosine A. Okay.
What?
Yeah. So it's cosine A squared
Equal 1.
equals minus sine A squared?
Yes, 1 minus sine A squared. There we go.
Or sine of alpha. But you need to write two functions. What's the other one?
can we do it the way that you did it?
Oh, cosine A equals sine A times tangent of A?
Right. I will say that's the other one
Sure. That's fine.
because I don't. Here I found. Let me see if I can find something else.
So then how do we indicate which formula to use for a given value of A?
We can say that the theory of the. What is the question? The theory of the fundamental identity say that it is with our hypotenuse equal 1. What's that? We should say that the fundamental identity of trigonometry.
Okay. So if you have the hypotenuse,
Great.
then you use the cosine A squared because then you already have the hypotenuse.
Right. But if you don't, you have to find the fundamental identity of trigonometry, establish that is to the.
If you don't, then you use the other one because you have the opposite over adjacent, and you're finding the only thing you have to find is the hypotenuse.
Great. We're done, dude. Are we?
Lottie, did you get your room clean?
Okay, man. I'm so done to eat for some to food.
That's
Nope.
my roommate.
What are you?
My bed's right there.
Okay.
Okay. So, all right, cool. We're done. I'll submit this quiz.
Awesome.
Hopefully, we get a good grade on it, and then, yeah. And then Vladdy, stay on a second. I'll figure out when I can come get the book from you.
Okay. Well, I'm gonna be there like early, so
I'm
be
gonna
Rexburg
be.
Text me.
I'll be in
Vladdy,
Rexburg.
start over here, or I'll text you and we can figure
What
it
time
out.
will you be in Rexburg tomorrow?
I'll be in Rexburg from
Bye.
6 o'clock in the morning until
Yeah, I'll
about
text you in like 5 minutes.
4 o'clock in the afternoon.